The next assembly we're going to discuss from Febco is two assemblies we're going to combine, which are the Model 835, which produced in sizes 3/4 through 2 inch. Production began in '68, discontinued in '73, and the Model 835B. It was unique in that the relief valve was mounted on the top half of the check assemblies. In other words, here's the same check mechanisms as we saw in the Model 805, but the relief valve mounted on the cover pointing on top of the check assemblies. This was replaced around 1973 and made till about 1978 in the Model 835B series. B was a modification that took place that changed the location of the relief valve. So what the 835B did is mounted the relief valve underneath the check valves. In the 835 series, it was mounted on top of the check, but 835B moved the relief valve to underneath it so that it had full discharge or full drainage capacity out of the check bodies in a backflow condition. Repair parts were very similar between the 835 and the 835B. In fact, there was only one O-ring that was different. But here you can see the check assemblies, the 805 with the flat tops, same check components as we saw there, obviously different spring loading, relief valve mounted on the bottom. Here's our relief valve cover, diaphragm, spring retainer spring, the body O-ring, stem and seat, and relief valve disc right there. So let's take a look and see what the 835 and the 835B look like inside. Check parts are still available for these models. Here's the 835 series where the relief valve is mounted on top, external relief valve sensing line. 835B. Checks the same as we saw in the Model 805. Remember, we've already taken these type of check assemblies apart with the flat tops. To remove the relief valve, the entire relief valve assembly would unscrew from the bottom after you disconnected your high pressure relief valve sensing line. Relief valve assembly would unscrew. Once the relief valve assembly unscrewed from underneath, similar to the 825 in construction relief valve seat came out. Once we removed the relief valve seat, turn it over, remove our relief valve cover. Underneath our relief valve cover would be our relief valve diaphragm, a single screw. Underneath our relief valve spring retainer would have our spring tension for the relief valve. Removing that screw, spring retainer, relief valve spring, and similar to the 825, we would push the stem out through here with the O-ring mounted through the center. 835 and 835B, main difference being the location of the relief valve. 835 series where the relief valve was on top, again not an approved assembly by today's standards. It was modified to an 835B where the relief valve was mounted underneath the relief valve. Rubber parts replaced. One disc holds a disc into the disc retainer. Cover, spring, putting our catch our spring retainer bolt. After we have that attached, now we want to get our relief valve diaphragm, relief valve cover. Once we tighten our cover in place, don't forget to put our relief valve seat back in. Mounting O-ring. That's our Model 835 and 835B reduced pressure assemblies from Febco. The next assembly we're going to discuss is the Febco Model 845, which produced in 3/4 through 1 inch sizes from about 1978 to about 1998. The backflow assembly is similar in repair parts and construction to the Model 825Y. The key difference was that the body was made of a glass fiber reinforced nylon instead of bronze. Rubber parts are very similar. The relief valve diaphragm was different. It had to have more holes in it because the relief valve cover had more bolts than the standard 825Y bronze body unit does. So this is the Model 845. Let's go ahead and take a look at it. Internal parts are exactly the same as 825Y on the check valves. As you can see, that Y pattern poppet style check. The only thing different on the relief valve on the 845 is that there are twice as many bolts through the relief valve cover. So the diaphragms were not interchangeable because on the 845 the diaphragm had more holes punched through it. By using the nylon, they had to have more holes to get a positive seal across the flange on the relief valve cover. But that's the Febco Model 845, 3/4 through 1 inch only, produced from 1978 to about 1998. The next assembly we're going to discuss in the Febco series is the Model 850s and Model 870 series of double check assemblies. The 850 is produced in sizes 1/2 through 10 inch. There's an 850B, which is used in the smaller sizes, 3/4 inch. There's an 850U in the small sizes, 1/2 through 2. 870 and 870V are in the larger sizes, 2.5 through 10. Double check assemblies, and a little different in construction between the 850 and the 870 in the larger sizes. Let's take a look and see what the 850 in the small size looks like first. The small size, it is a single access cover from the top, inlet shut off, outlet shut off, and the 4 test cocks located on top. Checks are modular inline construction. Here's a breakdown showing the assembly, inlet, outlet, with the check module in the body, and here's what the exploded of it looks like outside. As you can see, to disassemble it, you take the cover off from the top, remove your spacer, and there's first and second checks inside the body for the repair. The large model 850 in 2.5 through 10-inch sizes, inlet, outlet, shutoff, is a horizontal piping configuration. First check, second check, 2 independent check covers. Checks come out from the top on both of those checks. Here's a breakdown showing the 850 with the internal parts, check assemblies. Utilize a vulcanized clapper plate, not a flat rubber disc. Spring mechanism, there's 2 springs actually mounted with a stem through the center of them, looks like this. Cover comes off from the top, check springs are contained for the average repair. The Model 870 took the check body and put it into an angle configuration. Basically the same internal parts as we saw in the 850 in the 2.5 through 10-inch, but the 870 has a unique body design, so it has an inlet and outlet going up and down like you see here. Check body is not horizontal like the 850, but 870. The second check can be rotated 180 degrees. There's a groove coupling on the end between the checks here that allows the discharge to go straight up, and that's the V series pointing straight up. Now, because the center-to-center pipe configuration of this assembly is kind of unique when you're going to install it. Most backflow assemblies are a horizontal piece of pipe you cut out. This one's coming up and down. They make what are called valve setters. And the valve setter is designed to maintain that center-to-center pipe so that a backflow assembly with this shape can be easily cut into a piping system. This is the 870 series of double check. Febco also produces a Model 856 double check detector assembly, utilizing the main valve as an 850, the 2.5 through 10-inch main valve, utilizes the small 805YB as the bypass unit on that 856 double check detector assembly. And they also produce an 876 double check detector assembly with that up and down piping configuration, utilizing the bypass assembly of an 805YB on that also, as you see right there. So there's an 850, which is horizontal, 856, which is a horizontal double check detector assembly, 870 is the up and down vertically oriented double check, 876 is the up and down vertically oriented double check detector assembly. 850 is available in the small sizes, as we said, 1/2 through 2-inch also. So let's go ahead and break down the check assemblies and see what they look like inside. So I've got an 860 RP here on the table. Let's go ahead and take it apart. Looking at it from a standpoint of an 850 double check and an 860 reduced pressure principal backflow prevention assembly. Have a cutaway. First thing we're going to do is remove our check cover. There will be 4 bolts on the cover. Cover comes off, and the cover is directional, meaning it goes one specific way for reassembly. And the way you can tell is by that little line in the center. If I put it in the wrong way like this, the cover will not go on properly because it'll mount on here. And the reason it has to go that way only is for the location of that number 3 test cock right here. Anyway, so taking the 4 bolts off, cover comes off in one piece. Once the cover comes off, now we have to take the check assemblies apart. You can see here where the first check assembly is, and here's where the second check assembly is. And between the 2 checks is this piece called a retainer. The function of that retainer is to hold the 2 checks in the body. So the retainer has to come out first. Then the first check assembly comes out first, and then second check assembly will come out second. So do it from the top like we're supposed to. And second check will come out next. So what we're seeing inside the body is this. Our first check and our second check with the retainer between the 2, just like that. Now, earlier we talked about that important interface between the thickness of the disc and the rise of that check seat. In other words, the disc can only be penetrated by the seat a maximum of 1/3 of its thickness, and something has to stop at a check stop or a check limiter. That causes our problems with disc compression, because as that disc embeds into the seat, there's the false compression of pressure, which arbitrarily raises, or which momentarily raises that pressure in the area between the 2 checks, causing that disc compression problem. Anytime we have an inline check design like this, we have another problem, because not only does that disc and seat interface come to place, but also the movement of these check assemblies. In other words, these checks are held in by this retainer, but if there's any movement in here, it compounds the movement of this, especially with the second check, causing that disc compression issue, where the second check compresses inward, raising the pressure in this area between the two checks, causing our relief valve to drip momentarily. Anyway, to disassemble, as I told you, the retainer had to come out so that we could get the check assemblies out in that order. What's also important is to make sure we have the ability to get that retainer out. You'll notice, and here's a 2-inch one, notice with that check assembly that if that check assembly was held open, that stem protrudes through the back side. So think about it. If all of a sudden we had a more double check than an RP, if we had a rock stuck in that first check assembly and suddenly that pin was sticking out the back, we go to pull that guide up, it won't come out because that would be held open like that and the guide retainer would be holding in place. So if that check assembly has something holding it open, and it's more of a case on a double check than an RP, a rock or something like that, we've got to get that check assembly to close before we can pull the retainer, because otherwise the retainer will not come out from there. So if you have to, open the number 1 ball valve, flush something out to try to make sure that gets closed, and then the retainer should come out. So the only time you'll know you have that issue is when the retainer just won't come out of the body. Usual case is that. So once you have the check assembly out of the body, and here's a 2-inch one showing you, a little bit easier to see, what we're going to do is we have a mounting O-ring, we have our check seat, and we have our spring retainer. By grabbing both ends, small 1/8 turn rotation, we'll release the spring tension like this with my spring retainer, my spring, my disc holder, and my check seat. One screw holds the disc into the disc holder. Reassembly is going to be just the reverse. Go ahead and line up our check assembly. 1/8 turn rotation, putting the check assembly back together. Putting the checks back in to the body. We're going to have it looking like this after we've rebuilt our checks. Second check will have to go in first, just as before it came out last. It goes in first. Installing the check all the way back into the body, making sure that that O-ring that you see right there goes past that lip. If the O-ring is sitting out here like this, you're never going to get that retainer back in place. So it's important, critical, positively got to do it. Make sure that that check assembly has that O-ring mounted back inside like that. Now my first check assembly goes in next. Once I have the first check assembly in place, making sure my O-ring, same story, where the O-ring is right there, mounted in that area. Now my retainer should easily go into the body, just like that, holding the 2 checks in place. Now you can see the kind of movement we have in there. It's kind of tight, but you have a little bit of movement of those checks. As I told you, the check cover is directional, and the way you'll know is putting it back on top. If it's not correct, that bar will hit the retainer and won't be able to tighten the cover. So make sure you've got the cover the right way. And if this was an 850, that would be a double check, we'd be done. But since this is an 860, now we got to do the relief valve. Get the cover bolts back on this. Now, the relief valve mounted on the bottom, internal relief valve sensing line for the high pressure sensing line. First thing we're going to notice is on the relief valve cover, there's this different colored brass. It's called the yellow brass. It has to do with the composition of the amount of zinc and other materials in it. Yellow brass is not used in areas in backflow assemblies where it's a wetted surface. So anytime you see a bright yellow brass, notice on the test cock here, we have it here. Notice it on this cover, we have it here. Those are areas where there is no water. And that's one of the requirements. We can't use the yellow brass for wetted areas. It has to be the brown bronze like we see here. So I know there's no water behind that. So anyway, once it's shut off and turned off, opened all my test cocks. And that's a very important point on the I forgot to mention, on the inline check designs. Whenever you go to remove checks out of an inline body like this, make sure the number 4 and the number 2 test cock are open. Because as I go to pull that second check out of the body, if this test cock is closed, I'm creating a vacuum and pulling it, it'll never come out of the body. So very important that the 2 and 4 test cock be open when we pull checks out of an internal inline check design like that. Back to the relief valve. So the first thing I have to do is there's a little plastic piece here that we see. This is strictly just a little dust cover. It'll come off just like that, but stays on for the average repair and doesn't have to be removed. It's a good idea that it be there because it keeps dirt and debris from entering into that little breather hole. Okay? Next thing I want to do is loosen my hex bolt that you see with the yellow brass. All I want to do is just loosen it. It should be tight. And it does require to be loosened because it makes it easier for the repair process later. So once I've loosened it, just leave it like that. Once I've got that bushing loose, now I'm going to remove my relief valve cover bolts. And there will be spring tension underneath. So I want to release the spring tension under there. Like that. The stem assembly will come out in one piece attached to the cover, my relief valve spring, and inside you'll see is your relief valve seat, which is held in by adhesion of the friction of the gasket, just like that. There's my relief valve body. Now, let's take a look at the stem assembly. And I have a 2-inch one here, which is just a little easier to see than the small one. So the seat is pushed into the body, not held by anything other than the adhesion of that gasket. The relief valve spring sits over the seat. The guide sits in the center like this. So this is what you would be seeing inside that relief valve like that. Now, it uses a rolling diaphragm as the main elastic element of that unit. Here's my relief valve disc in the middle. What was the big deal with this nut? Well, let's go ahead and take that nut off now. And once we remove that nut, we're going to notice two things. One, we're going to notice a little white friction washer right there that's going to come off. And then the second thing we're going to notice is a small rolling diaphragm. A larger rolling diaphragm and then a smaller inner rolling diaphragm. The function of this rolling diaphragm on the outside like this is a guide. It makes sure that the relief valve stem is guided. In other words, the stem on the front, the guide that holds the disc, is guided here. It's also guided on the back side. Remember I said this was yellow brass, so I knew it wasn't open to, it didn't have any water in it? Well, that's how I know this is open to atmosphere, because as this guide sits in there like this, I'll take the friction washer out for a second. As the guide sits in there, the stem moves back and forth, and you can actually feel the piston moving air in and out at that point. So this outer rolling diaphragm is a guide for the relief valve stem. That friction washer is so that when I tighten this nut that I don't twist that rolling diaphragm, which is a very important point on all of them. Okay, so now I've got the friction washer out. I'm going to grab the stem and pull it throughout the body. There is a second friction washer mounted right here. So the two friction washers have the guiding rolling diaphragm encapsulated like this, and the nut pushing down on top of it. So let's go ahead and take the stem assembly apart now. I'll do it on the 2-inch size. It's a little easier to see. First thing you're going to notice, Phillips head screw on the back side and a nut on the front. So to disassemble this, we're going to get our Phillips head screwdriver, disassemble our assembly bolt. As we go to disassemble it, we'll notice that that nut comes off from the inside on the guide, like that, which gives me my relief valve guide here, my relief valve disc, my rolling diaphragm retainer, my rolling diaphragm, my small rolling diaphragm, my small diaphragm retainer, and then the assembly bolt on the end. So I showed you how it worked. In other words, this is a guide on the back side only. The only function for that lower one is to guide the stem as it travels back and forth as it travels on the front side. So my high pressure sensing line comes through my relief valve cover. You'll notice there's a hole right there in the top of the cover, an O-ring on it. That puts the high pressure on this side of the assembly. Low pressure comes through the body on the inside, putting low pressure on the low pressure side of that elastic element. Putting this relief valve stem back together is very, very important that we do it correctly. And when I say correctly, what I mean is tight enough. This is one of those times where we don't have an O-ring to assist us in our repair, and how tight we make it becomes critical. So we have our assembly bolt, inner rolling diaphragm retainer, large rolling diaphragm retainer, our relief valve disc. Now let's look at our guide for a second. In other words, that stem's going to come through here and that nut has to catch on the end. But if you notice close up that recess where that little head of that nut's going to sit is the same shape as that. So in other words, it sits perfectly flush like that. See? So there's a recess that nut sits into. That's how it has to be assembled, because if we leave it where it's out like this, like some nuts just sit on the outside of a stem, that would never tighten quite enough. So to make sure we have the proper torque, because we have to facilitate a water seal across these two rolling diaphragms. So we have to get an extremely tight seal with that one little assembly screw. And to get enough torque to make those two seal, they had to mount that nut into it so it was perfectly flush like that. So reassembling is going to be a matter of catching that nut. Once I do that, I want to go ahead and tighten that assembly bolt, making sure I maintain that nut into the retainer. Once I have it tightened, how tight does it have to be? Very tight. Because once I have it snug like this, I want to check it to make sure that that head of that nut is flush. But remember, I have to make a water seal between here, because remember, this is my high pressure sensing line on this side. Supplies high pressure, my sensing line on this side supplies low pressure sensing line. So if I had a leak across that bolt, what kind of differential would I have? None. And obviously the relief valve would leak very quickly. So it is possible, if that assembly bolt is not tight enough, that you'll have a leak across there and you wouldn't have the differential to give that backflow assembly working. So how tight does this have to be? Very tight. Remember, you're tightening a stainless steel bolt on a stainless steel nut. So although everything else is plastic, you should be okay, but make sure you have it as tight as you can get, because it'll be needed when you go to put it together. Let's put the 3/4 inch back into the body now. Again, we did the larger one because it was a little easier to see, because the small one's hard to see. So once we have the two diaphragms, rolling diaphragms attached, we're going to go ahead, first of all, put one of our friction washers on the bottom of our relief valve cover, pull our guide rolling diaphragm through from the bottom. Now, once I have it through, I'm going to let it drop down like this, because now I want to put my second friction washer here. And it's very important that I get that rolling diaphragm flat right there. Taking my bushing, making sure it's just hand tight at this point, just like that. You shouldn't have taken the breather hole piece off, but if you did, put it back at this point. Now, you'll see that that stem assembly is sitting up. In other words, I've got that flat on the bottom like that, so it's sitting there, but it's not rolled down yet. So to roll that inner diaphragm, what you have to do, with this just hand tight at this point, is grab both sides of the stem, pushing it back and forth. It'll fall down in place just like that. What I've done at that point is I've rolled that inner diaphragm. So back, and then it'll snap down like that. Once I have the rolling diaphragm in place, fold my large rolling diaphragm, relief valve seat, which just holds into the body by the adhesion of the gasket. Little application of a grease will help that stick to the body sometimes. Relief valve spring, to show you what we're doing here through the cutaway. Relief valve stem. Line up my two relief valve bolts. Make sure I have the O-ring on my cover for my relief valve sensing line. Go ahead and get my cover bolt started. Now, once I have my cover bolts started, this is our Febco 850 is the double check version, which is the check assemblies as we saw on the top. 860 is the RP version, as we saw with the relief valve underneath, 3/4 through 2 inch.